Hi, so this series is about doing some of the factorial notations and the binomial types of questions in induction unit. So first thing is that let's say we got to do the proof which was asked in 2018 November, paper 1 question. So you can't use calculator here. I start with this question as, let's say sigma r equals to 1 to n, r times r factorial is n plus 1 factorial minus 1. So what I can do is simply, if I take this entire series as an example, I can take that it is 1 times 1 factorial plus 2 times 2 factorial plus 3 times 3 factorial and so on, minus plus n times n factorial. I got to prove that this is n plus 1 factorial n minus 1. So what we get here is that, okay, if I take n equals to 1, my sum of the first term is actually 1 here. And let's take here, so it is right hand side is 2 factorial minus 1. So which is nothing but 1. So since my left hand side and right hand side is the same, so n equals to 1 is true. Now next is assume n equals to k is true, means some of the first k terms is true. So it will be 1 times 1 factorial plus 2 times 2 factorial plus dot 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 plus k times k factorial equals to k plus 1 factorial minus 1. Now if this is true, n equals to k plus 1 must be true. So I can take 1 times 1 factorial plus 2 times 2 factorial, k times k factorial, that's up till k terms. Now the sum of k plus 1th term, so it'll be k plus 1th term will be k plus 1 times k plus 1 factorial. And this ideally should give me, what should give me? Should give me k plus 2 factorial minus 1. When I replace this k with k plus 1, I get k plus 2 factorial minus 1. So this is what I got to prove. This is what I got to prove. Now what I'm going to do is, till here, if I look at the sum that I'm putting into the box here, this sum I already know. That is nothing but k plus that is nothing but k plus 1 factorial minus 1 and times, here it is k plus 1 times k plus 1 factor as it is. I'm not touching that. So which, if I pair this together, these two terms, I get k plus 1 factorial. If I remove common, what is left is k plus 1 here and plus 1, because here it is nothing, and minus 1. So it is k plus 1 factorial times k plus 2 minus 1. So now since we know that k plus 1 factorial is like k plus 1 times k factorial, or like n factorial is n times n minus 1 factorial. So using that logic, this part actually is nothing but k plus 2 factorial minus 1. And that's what I wanted. Now, final statement is, since it is true for n equals to 1, n equals to k, n equals to k plus 1, it is going to be true for the given statement, which is n belongs to the positive integer. So let's take another example on induction. Now here is the other example that is linked with the binomial expansion coefficient. So the question is that prove that 2 choose 2 or 3 choose 2, 4 choose 2 or 4 C2, n minus 1 C2 equals to n plus n C3. Now obviously this is true for n more than 3. That's what I have to say. So first is like, okay, verify for n equals to, let's say, 3. So it means that 2C2 plus 3C2 plus so let's say here what we get is 4C2 is this equals to